Hello everyone. Myself, Dr. M. Pavan Kumar Reddy, Assistant Professor, Department of Mathematics, VNR VIGNANA JYOTHI Institute of Engineering and Technology. Today, we learn how to evaluate double integrals in polar coordinates. So, last class we have seen evaluation of double integrals in Cartesian coordinates. Now, we discussed how to evaluate integrals in polar coordinates. Okay, double integrals in polar coordinates. So, what are the polar coordinates? So, in Cartesian coordinates, x and y are the variables. Whereas in case of polar coordinates, r and theta are the variables. Okay, r and theta are the variables. So here, let us consider that this is x-axis and y-axis. Of course, in polar coordinates, what is r represents and what is theta represents. So r is the distance of that curve from the pole and theta is the angle. Okay. Now, let us consider this is the region of integration here. This is the region of integration r. Okay, bounded by these two curves, let us assume. Bounded by these two curves. See here, the region is bounded by AB, AC, CD and BD. This is the region of integration. Okay, so if this is the region of integration, how to identify the limits? See here, always remember in case of polar coordinates, r limits are functions of theta. R limits are functions of theta and theta limits are constants. Theta limits are always constant since theta is an angle. Angle never be a variable. So, constant. See, the evaluate double integral is of the form in polar coordinates. It is theta 1 to theta 2, r1 to r2, f of r comma theta, dr d theta. Double integral, okay. Theta 1 to theta 2, r1 to r2, f of r comma theta, dr d theta. So, always remember in polar coordinates, always we have to integrate first with respect to r between the limits r1 and r2, where r1 and r2 are functions of theta. R1 and R2 are functions of theta and keep theta is fixed. First, while integrating with respect to r, we have to treat theta as constant. And then integrate with respect to theta between the limits theta 1 to theta 2. Okay, always remember here r1 and r2 are functions of x and theta limits are constants. So this is the way we evaluate integrals in polar coordinates. Let's see a problem. See polar in double integral 0 to pi by 4 integral 0 to a sin theta r dr d theta by root over a square minus r square. So clearly we have the inner integral limits are functions of theta. Obviously those are r limits. And 0 to pi by 4, this is angle. So these are theta limits. Okay. Let's consider this one. Integral 0 to pi by 4. Integral 0 to a sin theta. Okay. It is r dr d theta divided by root over a square minus r square. A square minus r square. This is, so theta varies from 0 to pi by 4 and r varies from 0 to a sin theta. Okay. It is r divided by root over a square minus r square dr d theta. Of course, here r limits are functions of theta. So first we have to integrate with respect to r, treating theta as constant. Later we integrate with respect to theta. Okay. See, first integral theta varies from 0 to pi by 4. Now, so integrating with respect to r. So what is the integrand here? R divided by root over a square minus r square. How to evaluate this integral? Okay. See, observe the numerator. It is r. Denominator is root over a square minus r square. We have a formula which is, I'm writing the formula here. Integral f dash x divided by root f of x dx. We have a standard formula here. Integral f dash x by root f of x dx formula is 2 root f of x. It is 2 root f of x. 2 root f of x. That means, but here what is root over f of x? So that means here f of x is a square minus r square. Say f of r, a square minus r square. What is the derivative of a square minus r square? It is minus 2r. You have r, but you don't have minus 2. Minus 2 we can introduce. Multiplying and dividing with minus 2. That is, so multiplying and dividing with minus 2. I am writing minus 1 by 2 outside, and r varies from 0 to a sine theta. It is minus 2r divided by root over a square minus r square into dr d theta. Dr d. Now observe, this is clearly in this form, f dash x by f root f of x dx. So therefore it is equals to minus 1 by 2 integral theta varies from 0 to pi by 4. So what is the formula? F dash x by root f of x is 2 root f of x, that is 2 root a square minus r square. Upper limit is a sine theta, lower limit is 0 into d theta. This is equals to minus 1 by 2. This 2 is constant now, which can be written outside. So 2 integral theta varies from 0 to pi by 4. Let's substitute the limits. Since we integrated with respect to r, instead of r we have to substitute a sine theta, that is root over a square minus, instead of r a sine theta, that is means a sine theta whole square, and a square sine square theta, which is a square sine square theta. Now substitution of lower limit minus, instead of r 0, that is root over a square minus 0, it is a square into d theta. This is equals to, of course this 2 gets cancelled. So minus integral theta varies from 0 to pi by 4. Okay. Let's simplify this. See, under root you have a square minus a square sine square theta. Let's take a square common and bring it to outside of the square root, which comes as a. So then it is root over 1 minus sine square theta minus root over a square is of course a into d theta. Now this is equals to minus, let's take this a common, write a outside. Integral theta varies from 0 to pi by 4. Now a common, no, root over 1 minus sine square theta. As we know, 1 minus sine square theta, cos square theta. So root over cos square theta minus 1 into d theta, which is equals to, say, minus a, integral theta varies from 0 to pi by 4. What is square root of cos square theta? As you know, simple, it is square root gets cancelled, cos theta minus 1 into d theta. This is equals to minus a. Let's integrate this with respect to theta now. What is cos theta integral? Cos theta integral is sin theta. Minus integral 1 d theta. Upper limit pi by 4. Lower limit 0. This is equals to minus a. Let's substitute upper limit first. Sin pi by 4. Minus pi by 4. Substitution of lower limit minus 0. Sin 0. Substitution of lower minus into this minus becomes plus. Theta is 0. So this is equals to, now see, what is sin pi by 4? Sin pi by 4 is 1 by root 2 minus pi by 4. So therefore this can be written as, now if you bring this minus inside, we have now it is pi by 4 minus 1 by root 2 into a is the answer. So this is the way we evaluate double integral in polar coordinates. Okay, I hope you understand. So let's see here, now limits are given, we evaluated double integral in polar coordinate. Let's see a problem which limits are not given, how to identify the region of integration and how to identify the limits and how to evaluate the integral in polar coordinates. Let's see a problem. Okay, now evaluate double integral r sin theta dr d theta, where r is the region bounded by the cardioid r is equals to a into 1 minus cos theta above the initial line. What is the meaning of initial line? See here, first let us consider the Cartesian plane. Okay. Now, initial line is nothing but x-axis. X-axis is the initial line. So, in polar coordinates, initial line is nothing but theta is equals to 0. Theta is equals to 0. Now, y-axis is nothing but what is actually theta represent in polar coordinates? Angle. So, y-axis makes an angle of 90 degrees with the positive direction of x-axis. So, this is the line theta is equals to pi by 2. Remember that? Okay. R is equals to constant. R is equals to constant represent a circle in polar coordinates. Okay. Whereas theta is equals to constant represent a straight line in polar coordinates. So theta equals to 0 is the initial line. This is called initial line. Initial line. Now, actually, what is cardioid? How this curve looks like? R equals to A into 1 minus cos theta. Okay. This you remember this curve. This curve looks like R is equals to A into 1 minus cos theta. R equals to A into 1 minus cos theta. Actually, the curve looks like this. This is the entire cardioid. Actually, this is the cardioid. It's the cardioid. But here, we have to consider a region above the initial line. Above the initial line means x-axis. Above the x-axis. Above the x-axis. So, above the x-axis means what is the region of integration here? So, the region of integration is, see, above the initial line. So, the region of integration is this one. So, this is the only region of integration. Okay. This is the region of integration. So, in this region only we have to evaluate the integral. Okay. Let's consider that in case of Cartesian coordinates, we consider a strip in the region. Whereas in case of polar coordinates, we consider a wedge in the region. Like the strip only, let us consider that. Let us consider a strip in the region. Let us consider that a strip in the region like this. So, like this with some angular thickness delta theta. With some angular thickness delta theta. Okay. So, this is the strip we are considering. So, where the strip has its ends. See, lower end of the strip is at pole. What is pole? Pole is r equals 0. Pole. So, pole, a point, the distance of that point from pole is called r. So, distance of origin from origin is 0. So, r equals to 0. This is. And distance of this point, okay, on the curve from pole is represented by the cardioid. So, r is equals to A into 1 minus cos theta. That means one end of the strip is moving at r equals to 0. The another end of the strip is moving on the curve r equals to A into 1 minus cos theta. So, to cover this entire region, this strip has to slide from the line theta is equals to 0. So, theta is equals to 0 to it has to cover this region entire. So, it has to, this strip has to move this like this. Okay. So, like this it has to move. Okay. So, theta is equals to 0 initially. So, it has to move theta is equals to pi by 2 like that, so on. Theta equals to pi. So, therefore, this is the line actually which is making an angle of pi degrees with the positive direction of x-axis. So, this line represents theta equals to pi, negative side of x-axis. Theta. So, theta varies from 0 to pi. R varies from 0 to A into 1 minus cos theta. So, therefore, see the region R is symmetric about the line . Okay. So, region, don't write this. See, it is, we consider actually cardioid is symmetric about, not the region. Cardioid is symmetric about the initial line. Region is above the initial line only. Region is above the initial line. See here the cardioid R is equals to A into 1 minus cos theta is symmetric about the line, symmetric about the initial line. initial line is nothing but, remember, it is theta is equals to 0. So here the region of integration is only above the initial line. So region is R is the region above the initial line only, above the initial line. So here, therefore, R varies from 0 to a into 1 minus cos theta. Theta varies from 0 to pi. 0 to pi. Let's evaluate the integral. Therefore, double integral over the region R sin theta dr d theta, which is equals to theta varies from 0 to pi, R varies from 0 into 1 minus a into 1 minus cos theta, R sin theta dr d theta. Of course, R limits are functions of theta. First we have to evaluate with respect to R, then with respect to theta. That is, so while integrating with respect to R, we treat theta as constant. So sin theta is constant. R integral R dr, R integral is R square by 2. R square by 2. Upper limit a into 1 minus cos theta, a into 1 minus cos theta, lower limit 0 into d theta. Into d theta. Let's substitute the limits. Okay. Now, which is equals to, it is integral theta varies from 0 to pi. Let's substitute the limits first. Sin theta. Now, instead of R, we have to substitute the limits a into 1 minus cos theta, upper limit, 0, lower limit. R equals to a into 1 minus cos theta. So, R square. That is a square into 1 minus cos theta whole square divided by 2. Substitution of lower limit. So, instead of R, a into 1 minus cos theta. That is a square 1 minus cos theta whole square by 2. Minus substitution of lower limit is 0. Lower limit has no contribution. 0 by 2, 0 into d theta. Now, this is equals to, let's simplify this. This is theta varies from 0 to pi, which is now sin theta into, this a square is constant now, which can be written outside of the integral, 1 minus cos theta whole square. 1 minus cos theta whole square into d theta. Of course, this 2 also we can write outside. Now, how to evaluate this integral? How to evaluate this integral? We can use substitution method also. 1 minus cos theta equals to t, and you can proceed. Okay, I'm not using substitution method. Since we have a direct formula, what is the direct formula is? I'm writing the formula here. See, integral f of x whole to the power of n into f dash x dx. F of x whole power n into f dash x dx equals to, it is f of x to the power of n plus 1 divided by n plus 1. Observe here, what is f of x here? Assume 1 minus cos theta is f of x. If you assume, say f of theta, 1 minus cos theta. What is actually 1 minus cos theta derivative? Derivative of 1 minus cos theta is 1 derivative 0. Cos theta derivative minus sin theta. Minus into minus plus. So it is sin theta. That means, so this is f of theta. If this is f dash of theta. That means this sin theta is the derivative of 1 minus cos theta. That means we can use this formula as 1 minus cos theta as f of theta. F of theta power n into f dash of theta d theta is f of theta whole to the power of n plus 1 divided by n plus 1. Upper limit pi, lower limit 0. Okay. This is a square divided by 6. I am writing this 3 outside. Now, substitution of the limits. Pi, instead of theta pi, it is 1 minus cos pi whole cube minus substitution of lower limit, 1 minus cos 0 whole cube, which is equals to, it is a square divided by 6. What is cos pi? Cos pi. Cos pi can be written as cos pi plus 0 degrees. Cos pi plus 0 degrees is cos 0 degrees. Pi plus theta, third quadrant. Third quadrant cos is negative. So therefore, cos 0 minus cos 0 1. So answer is minus 1. So cos pi is minus 1. So 1 minus of minus 1 minus of minus 1. Okay. Whole cube minus cos 0 1. 1 minus 1 0. No contribution. Which is equals to a square divided by 6. 1 minus of minus 1 plus 1. 1 minus plus 1 plus 1 plus 1 2. So it is 2 cube. Which is equals to it is 8a square divided by 6. Can be further simplified as it is 4a square divided by 3. So is the value of the integral. Okay. I hope you understand. See, this is the standard figure of cardioid that you need to remember. R equals to a into 1 minus cos theta. This is, since he asked to evaluate the integral above the initial line, so this is the region of integration. Consider a strip, identify the limits. One end of the strip is moving at pole. In case of polar coordinates, origin is called pole. Okay, so the pole is at a distance of 0 from pole itself. So R equals 0. And this is the another end is at on the curve, which is R equals to a into 1 minus cos theta. So these are the limits of R. To cover this entire region, this strip has to slide from the line theta is equals to 0 to theta equals to pi. Okay, so this is the way we evaluate the integral. This is if limits are not given, we identify the limits and we evaluate the integral in polar coordinates. Okay, so try to work out these two problems. Okay, so one is limits is given. Okay, another one is limits are not given, and identify these two curves and the region of integration and evaluate the integrals. Okay, thank you. Any doubts, you can contact me on this mail, Pavan Kumar Reddy _m@VNR_VJEC.in. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.